And we have another question. This will be, if I look, this will be question number 4. Okay, yeah. This will be question number 4. I'll just expand this question. Okay. So we need to find the characteristic polynomial of the matrices. So this is, I'll start writing with the red color now. I just like writing with different colors. So question number 4, characteristic. Don't judge my handwriting because on whiteboard it doesn't look good. Characteristic polynomial of the matrices. So instead of starting with this question, I'll just tell you a brief about, or I'll just tell you the procedure. So for finding the character, like if you have heard the term of eigenvalues or eigenvectors, then like characteristic polynomial equation of a matrix is basically used to find eigenvalues and vectors. So yeah, and if you haven't heard the term of eigenvalue, eigenvector, then it is a very like common term in physics and in engineering. So like on daily basis we calculate eigenvalues of matrices or vectors, and so to find the characteristic equation, what we do is that, suppose I have a matrix, let's say a x. X is a matrix. So for characteristic equation, characteristic, not equation, polynomial, what we do is that we take X matrix, we subtract it from the product of lambda times I, and we take the determinant of this. Now I'll tell you, lambda here are nothing but eigenvalues. Eigenvalues. I is nothing but the identity matrix, and the length of the I matrix will be equal to the length of this X matrix. And so in this way we find the characteristic polynomial equation, the characteristic polynomial. And if we just equate this determinant term equal to 0, then we are going to get an equation which we can use to find the eigenvalues. But here we are not talking about the eigenvalue equation, so I won't be talking about it. So what I have to do, I'll just start with the first part. Just a minute. So the first part, the first matrix is A matrix. It is given as 1, 0, 2, 3. So I'll just follow this procedure. First I will write the A matrix, then I will subtract it from lambda times I matrix, and I'll take a determinant of this whole thing. Now I'm going to write this. So my A matrix is 1, 0, 2, 3 minus lambda times, so my I matrix will be of 2 cross 2, so this will be 1. Here I will have 1, and here 0 and 0, and definitely I'm going to take a determinant of this thing. Yeah, so I'll just multiply this lambda. So this, as this is a scalar number, so this will be multiplied with each and every term of this matrix, and this will be lambda and lambda. So determinant 1 0 2 3 minus lambda 0 0 and lambda. Now I'm going to subtract these two matrices. So subtraction is carried out simply like each and every element is multiplied with the corresponding element of the other matrix. So this one will be sorry, not multiplied, subtracted. So this one will be subtracted with lambda. So again a determinant 1 minus lambda. Then there is nothing for second term, nothing for 2, and this will be 3 minus lambda. Now finally I'm going to take the determinant of this. So I'll multiply these two terms minus these two terms. So the product of these two will be 1 minus lambda, 3 minus lambda minus 2 times 0. So this will be 0 and I'll just multiply these two equations. So this will be 3, these two terms, so this will be 3 and this will be minus lambda minus 3 lambda minus minus plus lambda square. This will be lambda square minus 4 lambda plus 3. So this should be the characteristic characteristic polynomial for the first this A matrix. I'll just cross check it with the solution given, lambda square minus 4 lambda plus 3. So again here we can see that the same kind of procedure is followed. I will go for the second one. So my B matrix is, it is a lot easier to deal with 2 cross 2 matrix, and if we have a 4 cross 4 or more than a 3 cross 3 matrix, then it is better to just ask the computer to solve it for you. So I will just write, it will be for polynomial characteristic polynomial, it will be b minus lambda times I. So this will become determinant of 2 minus 1 minus 1 2 minus lambda times, again my I will be of 2 cross 2, so 1 and 1 0 0. Now again I'll just multiply this lambda with each and every element of this matrix. So this will be 2 minus 1 minus 1 2 minus lambda 0 0 lambda, and I'll go for the subtraction. This 2 is not clearly visible. Yeah, I'll just go for the subtraction. So this will be 2 minus lambda, negative 1, negative 1, and this will be 2 minus lambda, again, yeah. So 2 minus lambda, yeah. And I need to take a determinant of this. So again, I'll just multiply this 2 minus lambda with 2 minus lambda. Minus, this will be minus 1 times minus 1, this will be plus 1. So this is nothing but 2 minus lambda whole square. I'll just use the identity of a square minus b square. Sorry, a minus b whole square. So this will be, a square will be 4 minus, sorry, plus b square will be lambda square. This will be minus a square minus b square, a square plus b square minus 2ab. So 2 times 2 into 2, so this will be, sorry, 2 times into 2 4, and this will be lambda, and again we have a -1 here. So this will be lambda square minus 4 lambda plus 3. I hope I haven't done any calculation error. So minus 4 lambda, then it is plus 4, then lambda square, and that was -1. So let's check the solution given here. The final is lambda square minus 4 lambda plus 3. So yeah, voila. So my solution is correct. I will go with the C matrix now. So C is a 3 cross 3 matrix. Let's see how much lengthy calculation we have to go for. 0, 0, 2. And then again for characteristic polynomial, it will be C minus lambda times I. And now this will be determinant 2, 1, 2, 0, 3, 2, 0, 0, 2 minus lambda times. Now my I matrix is going to be a 3 cross 3 matrix. This will be I, and rest all will be 0, and again a determinant. Now again I'm going to just 2, 1, 2, 0, 3, 2, 0, 0, 2 minus this will be lambda, 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 0, 0 and zeros. Now I'll go for matrix subtraction. This will be 2 minus lambda. This will be 1, 2, 0, 3 minus lambda, 2, again 0, 0 and 2 minus lambda. Now I'll take the determinant. So for taking the determinant of a 3 cross 3 matrix, what we do is that we fixed first row and first column, then we multiply these two terms, then we subtract these with this, and we multiply that whole with this term. So it will be 2 minus lambda times, so I'll just fix this first column and first row. This will be 3 minus lambda times 2 minus lambda, 3 minus lambda, yeah, 3 minus lambda, 2 minus lambda, minus 2 times of 0, so 2 into 0. For the second one, we just add a negative here, and then this is 1, so I'll just write 1 here. I'll fix this one and this one, so I'll just fix the second column and first row. So this will be 0 into 2 minus lambda minus 0 into 2, and again plus the last term is 2. So this will be this column will be fixed and this row will be fixed. 0 into 0 minus, I'll just write a 0 here. Okay, so we can clearly see that this will be 0, this part will be 0. So we'll have just these three terms. What happened? Oh, okay. Red color. So we'll have a product of these three terms only. So I'll just write 2 minus lambda, 3 minus lambda. This will be 2 minus lambda. So I can clearly see that we have two minus lambda terms. So I'll just write this as 2 minus lambda whole square and then 3 minus lambda. Now I'll again use the a minus b whole square identity here. So I'll write 4 plus lambda square minus 4 lambda times 3 minus lambda, and now I'm going to multiply these two terms. So this will be 12 plus 3 lambda square minus 12 lambda, then this is minus 4 lambda, this will be minus of lambda cube, and this will be minus of 4 lambdas plus of 4 lambda square. I'll just cross check 3, this will be minus, and this will be minus, minus and plus. Yeah. So first we'll start with the highest power term. Lambda cube is alone. So I'll write minus of lambda cube. I don't like this lambda. Minus of lambda cube. Then we'll go for square term. So we have 3 square and 4 lambda square. So 3 lambda square, 4 lambda square. So that will become 7 lambda square. Then we have, we'll go for lambda term. So this will be minus 12 minus 4. So this will be minus of 16 lambda, and then last term is 12. So let us look at the solution given for the C matrix. Lambda negative lambda cube plus 7 lambda square minus 16 lambda plus 12. Yeah. So the solution for C part or the C matrix is also correct. Now we'll go for D matrix. Like these kind of questions are a little bit lengthier because for each and every matrix. So for this D part, I'll just tell you one trick. So instead of going, we can just skip this step, and this step. So we can just skip these 3 steps. I'll just highlight these 3 steps. So this one, and this one. We can just skip this, and we can just write like it is a shortcut, but if you do not have a lot of practice with matrices, then I will suggest that you should not follow this kind of approach. But yeah, if you have some kind of practice, then definitely go for this because it will save a lot of your time. So instead of writing these 3 steps, what you can do is that just take the matrix for which we have to do the operation, and for on the diagonal terms just subtract lambda. So yeah, we can clearly see that whatever matrix we had, this lambda was coming in the diagonal term with a subtraction sign. So to save a little bit of time, I'll just follow that approach for D matrix because D question is going to be little bit lengthier. I was playing with red pen. So D matrix is 3 minus 1 minus 1 minus 12 0 5 4 minus 2 minus 1. The characteristic polynomial will be D minus lambda times I. Now I'll just straight away write this. Magnitude of D minus lambda times I will be magnitude. Now I'm going to write this in a separate, like I'll just give a little bit of space. 4 minus 2 minus 1. So I'll go with the shortcut here. So I'll just subtract lambda from the diagonal elements and minus of lambda. Now I'm going to take the determinant. So I'll just fix this first column and first row. So this will be 3 minus lambda. This is 0 minus lambda times minus 1 minus lambda minus 2 times 5, then minus 1 times, this will be for second column will be fixed and first row will be fixed. So minus 12 times minus 1 minus lambda and minus this into this, minus 4, 5 is 20, just write 20 here, then plus the last one, minus 1 times this one will be fixed, the first row is going to fix and the last column will be fixed. So this will be minus 12 times minus 2 and then minus, and then this will be 4 times minus lambda because 0 will be separated. So we'll just go for the multiplication. This is going to be a hectic job. So this, I'll just skip this 3 minus lambda multiplication first. So this will be 2 5s are 10 and minus minus will be plus, so this will be plus 10 and this is 0 minus lambda, so it will be minus lambda. So minus and this minus minus will become plus, so lambda times 1 plus lambda, 1 plus lambda, and this will be plus 10 and this minus minus will become plus minus 12, and again I can take minus sign common, so this will be 12 lambda plus 12, then minus 20 and this will be minus 1, minus minus again plus, so this will be 24 and this will be minus 4 lambda and this minus minus plus, so plus 4 lambda. Now what I will do, this will be lambda plus lambda square plus 10, so this is 3 minus lambda lambda square plus lambda plus 10 and this will be plus 12 lambda, this will be negative 8 and this minus sign I'll just multiply, this will be minus 24 minus 4 lambda. Now I'm going to just go for the multiplication, so this will be 3 lambda square, 3 lambda square plus 3 lambda plus 30 and this will be minus lambda cube, my page is ending, minus lambda cube, then this will be minus lambda square and minus 10 lambda, then again plus 12 lambda minus 8 and then plus minus 24 minus 4 lambda. First I'll start with lambda square, lambda cube, higher power element. There we just have 1 lambda cube, then I'll go for the square terms, so I have these two terms for square, so this will be 3 minus 1 will be 2, so this will plus 2 lambda square. I think we do not have any square terms here, this is only in first power, yeah, so we'll go for the lambda terms. So we have 3 Then we have 12 and minus 4. So 3 and 12 will be 15 and minus 4 will be 11. I hope this is correct. I can definitely make the calculation error. And this will be 30 oh sorry, we had a negative 10 also here. I knew that I am going to make any mistake. So 3 minus 10, so this will be minus 7, and then we have plus 12, so minus 7 plus 12 will be 5, 2 and 5, yeah. This till this we have 5, then 5 minus 4, so this will be only lambda. And for the lambda power 0 term, this is 30 minus 8 minus 24. Just to be quick, I'll just go with the calculator. 30 minus 24 minus 8 minus 2. This is minus 2. I hope that for D matrix this is the answer. Like for such kind of long calculations we can definitely make mistakes. So minus lambda cube plus 2 lambda square plus lambda minus 2. Yeah, so the answer we have got is correct, and again it is matching with the solution given here. So the solution is also given in the similar manner. Yeah, so here also they have gone for the direct approach or shortcut, but I'll just suggest you that if you do not have practice with matrices, then please go with these steps because you can make mistakes here. Correct solution. Good work.